Hello, everyone. This is Dr. Sri Banerjee, Dr. B. And in this recording, I will be going over some of the confusing elements of biostatistics, which students are having some difficulties understanding. Um, Most of you are doing pretty well in understanding and trying to figure out what it is exactly that you have to run in SPSS. It is not a easy program to run and learn for the first time. However, as I'm seeing the visuals and all of the different descriptions of the different weeks, I'm beginning to see that you're understanding the concepts well in terms of having to run the analysis. However, I want to go back and fine tune some of the conceptual areas which students oftentimes have difficulties in understanding what it is. So confidence intervals is one of those areas which oftentimes is counterintuitive when a student is encountering this definition. What I suggest that you do for starters is try to memorize what a confidence interval is. Once you do that, then you can kind of understand where it ties in with very important sort of considerations when we're talking about precision and accuracy. So the concept of precision and accuracy are extremely important when we're thinking about confidence intervals, is because when you're thinking of precision, you want to think of consistency. So is what you're doing consistent? So the caveat here is that consistency doesn't always mean the same thing as accuracy. So let's take, for instance, a dartboard and think about this in terms of a dartboard. So you could be shooting the dart and throwing the dart at the dartboard, and every time landing at the furthest possible point away from the bullseye. So if you're consistently throwing the arrow, throwing the dart at the furthest point in the same place, though, consistently, after repeated throws, after 10 throws, maybe you're hitting it at the same place, then that would be considered precise. However, it's low in accuracy. So you might have precision, but you don't have enough accuracy. On the flip side, you can have a lot of throws that are kind of landing around the bullseye, but not really quite making it. So then that is a low precision, but again, accuracy is higher there. Okay, so I hope that kind of makes sense and helps you understand the point here with confidence intervals. So we have to make some determinations here. When you're thinking about 95% confidence interval, you're thinking about plus or minus two standard deviations from the mean. So anything more extreme than two standard deviations of the mean might actually point towards significance. But significance is something I'll go over on the next slide. Here, it's extremely important to understand what happens when this confidence interval, which is one of your quiz questions, one of your assignment questions that you had, where extending the confidence interval from 95 to 99, what does that do? Well, you can see here that you have a 95% confidence interval, and I'm going to underline this here, right here, and then I'm going to use another color to designate the 99% confidence interval. So I'm going to use blue. And then once you do that, you see that when you widen, think about this as the bullseye. Think about the red as the bullseye. So when you widen that red bullseye and make it the blue bullseye from our analogy of the dartboard, um, it's a much larger area for you to throw the dart at. So you're going to make it more times in within the bullseye if you're in the blue bullseye versus the red bullseye. So this is a very hands-on sort of way to illustrate confidence intervals, after which you should not ever be confused about this. But try to, if you're still confused, try to pause this recording at this point and rewind back and listen to my explanation one more time, and see if you are able to make sense of this confidence interval concept. So as you increase the size of the confidence interval, um, accuracy is a lot more, because you're more likely to land in the blue bullseye than the red bullseye. So that's the explanation there. Okay, so now shifting gears from confidence interval to talking about p-values. So p-values are also another important aspect here. About p-values, let's take an example here. So what is a p-value? If we look at an example, maybe you'll be able to see this a little better. So the p-value quantifies the probability of getting at least two populations with two different means, given that the null hypothesis is true. So let's break this apart. I know it's a lot of words, but first part I want you to emphasize, emphasize in your mind is, given that the null hypothesis is true. So that is very important to keep in mind. So given that the null hypothesis is true, basically this is saying, what is the probability of getting two population means, of getting a more extreme population mean, if you're talking about means, or getting at least two populations with two different means. So it can vary based on the type of test that you're running. But the one thing that you always see is in the definition is that you're assuming that the null hypothesis is true. So given that the null hypothesis is true, what is the likelihood, whether it's two separate means or a more extreme sort of mean than what is included within the null hypothesis? So height versus gender, when we're thinking about that, typically we think of male versus female. So height, the mean height for males and females are equal. That's the null hypothesis. And then the alternative hypothesis is that the mean height for males and females are not equal. So this is a sample one, and you should be constructing these for every single research question that you've created. Transition from talking about p-values to talking about type 1 error. What's the relationship? I want to give you a moment. I'm going to pause here to think about that relationship. Okay, so the relationship between p-value and alpha, or type 1 error, is that basically the p is set at anything less than alpha. So alpha, which is type 1 error, which is known as a false positive. So when the researcher actually incorrectly rejects the true null hypothesis, then that is a type 1 error. So you're actually reporting something significant, which is not. So we want the p-value to be more extreme. So what that means, what more extreme means, is that you want a p-value that is less than the value set at alpha. So if alpha is 0.05, we want the p to be less than alpha. So that's why type 1 error is so important to keep in mind when you're thinking about some of these concepts. And then finally, I'm going to end with this. This is called a confusion matrix for those of you that may not be familiar with this, a 2x2. But this really illustrates the point that if you reject the null and the null hypothesis is actually true, then that's type 1 error. Now, type 2 error is accepting a false null hypothesis. So maybe you did not reject the null but because of your p-value, but the p-value was actually supposed to be significant. So you falsely accepted the null, or falsely did not fail to reject the null. So the wording is confusing, but accepting a false null hypothesis is the best way to characterize type 2 error. And if you subtract 1 minus type 2 error, then you can get beta. That's another measure that is important, not really important for the purposes of this class. So in summary, I've gone over the concepts of confidence intervals, the concept of p-value, and also type 1 and type 2 error. These are often, again, confusing terms. If you don't understand them in this lecture, you can go ahead and pause and listen to my some of the segments a little bit more in detail. But for now, I think this should give you a brief overview of these concepts. If you have any additional questions, please don't hesitate to contact me. Thank you.